Hello again and welcome to the Steck Academy, where today's topic is limits part 3. Previously we've looked at limits as x approaches infinity and also as x approaches negative infinity, not to mention occasionally a limit as x approaches a constant. Today we're going to do something a little more challenging and work with limits as x approaches a constant of a variety of rational functions. Now, the approach that we've seen in the past that has worked nicely has been to substitute a value for x in place of x. So if we're approaching a limit of 2, then it would be simple enough to plug in 2 for x and evaluate the expression and see what we end up with. So I'm going to replace x with 2, as you see here, and then we'll simplify the numerator. 4 plus 2 is 6, 6 minus 6 is 0, and we'll simplify the denominator. 4 minus 6 is negative 2 plus 2 is also 0. So unfortunately what we have obtained is what's called the indeterminate form, that is 0 divided by itself. So we'll have to go to plan B and see if there is some other way in which we can determine the limit of this rational function. One of the options available to us is to consider factoring the numerator and denominator. And occasionally when we factor, we find out that the fraction is reducible or simplifiable, I guess is a better way of saying it. So I'm going to provide some factors here for the denominator and some factors for the numerator. And then we'll step back and take a look at those factors in the numerator and denominator. Well, you'll notice right away that in the numerator and denominator, we have a common factor of x minus 2. And since we know that any factor divided by itself is 1, we can eliminate that common factor and rewrite this as the limit as x approaches 2 of the new, simpler rational function, x plus 3 divided by x minus 1. Okay, now we're in a position to substitute for x again, and we'll see what we get this time. Replacing x with 2, the numerator is 5, the denominator is 1. So the limit as x approaches 2 of this rational function would appear to be 5. Now in subsequent examples we'll look at some additional limits of either rational functions or other expressions that are a bit more challenging than this, but at least for starters, here is a typical example of finding the limit at a particular value of a.